Long before familiar forests of oak, pine, or tropical rainforests spread across the continents, there existed a world of vegetation so vast and so strange that it feels almost impossible to imagine. These were forests unlike anything alive today, towering, dense, and alien in structure. They stretched across entire regions of the planet, shaping the air, and the very rhythm of life. And yet, despite their dominance for millions of years, they disappeared so completely that their absence is almost as profound as their existence. To understand these giant forests, it is necessary to step back into the Carboniferous period, more than 300 million years ago. At that time, much of the land near the equator was covered in warm, humid wetlands. The climate was stable, rainfall was abundant, and vast swampy environments created the perfect conditions for plant life to thrive on an unprecedented scale. But these were not forests in the modern sense. There were no flowering plants, no grasses, and none of the trees that define landscapes today. Instead, the forests were dominated by enormous lycophytes, ancient relatives of modern club mosses. Among them were species like Lepidodendron and Sigillaria, plants that grew into towering giants, reaching heights of over 30 meters. Their trunks were thick but relatively soft compared to modern wood, covered in distinctive patterns left behind by fallen leaves. At their tops, they carried clusters of narrow leaves, forming a canopy that filtered light into the humid air below. Standing within one of these forests would have been a disorienting experience. The trunks rose straight upward, often unbranched for most of their height, giving the landscape a uniform, almost geometric appearance. The air was heavy with moisture, and the beneath was often submerged in shallow water. Light struggled to penetrate the dense canopy, creating a dim, green-tinted atmosphere filled with drifting spores. These forests did not rely on seeds to reproduce. Instead, they used spores, tiny, lightweight particles released in enormous quantities. This method of reproduction required constant moisture, as spores needed water to complete their life cycle. In the wet, stable environments of the Carboniferous, this was not a limitation, it was a strength. Alongside these towering giants grew other strange forms of vegetation. Giant horsetails, known as calamites, rose in clusters with segmented, hollow stems. Ferns spread across their fronds unfurling in the damp air. Seed ferns, an unusual group combining features of both ferns and seed plants, added further complexity to these ecosystems. Together, they created layered environments that supported a wide range of life. Over millions of years, these forests expanded across vast regions. They played a crucial role in shaping the planet's atmosphere, absorbing carbon dioxide and releasing oxygen. In fact, oxygen levels during this period were significantly higher than today, partly due to the immense productivity of these forests. But their influence extended beyond the air. When these plants died, they often fell into waterlogged environments where decomposition was slow. Layers of plant material accumulated over time, compressed under sediment and pressure. This process would eventually form coal, one of the most important energy resources in human history. Entire coal deposits found today are the fossilized remains of these ancient forests. Despite their success, these forests were not invincible. As the Carboniferous period came to an end, the Earth began to change. The climate, once stable and humid, started to shift. Tectonic movements altered the distribution of land and sea, affecting weather patterns and rainfall. Gradually, many of the vast wetlands began to dry out. This change was subtle at first, but its effects were profound. The spore-based reproduction system that had allowed these plants to dominate became a vulnerability. Without constant moisture, spores could not reliably develop into new plants. As environments became more seasonal and less predictable, the life cycle of these giants was disrupted. At the same time, a new type of plant was gaining an advantage: seed-bearing plants. Seeds offered protection, stored nutrients, and the ability to survive in drier conditions. This innovation allowed seed plants to spread into areas where spore-producing plants struggled to survive. The balance of power began to shift. The giant forests did not vanish overnight. For millions of years, they persisted in shrinking habitats, retreating into regions where conditions remained favorable. But the trend was clear. Their dominance was fading. Then came a series of events that would accelerate their decline beyond recovery. Toward the end of the Permian period, around 252 million years ago, Earth experienced the most severe mass extinction in its history. Massive volcanic eruptions released enormous quantities of greenhouse gases into the atmosphere. Temperatures rose dramatically, climates became unstable, and ecosystems across the planet were pushed to their limits. For the already declining giant forests, this was a final blow. The remaining wetland environments disappeared or became fragmented. Conditions became too harsh for their reproduction and survival. Entire lineages that had once dominated the planet were reduced to nothing more than scattered remnants, and then, eventually, nothing at all. What makes their disappearance so remarkable is not just that they went extinct, but how completely they vanished. Unlike some plant groups that left behind descendants or close relatives, many of these giants have no true modern equivalent. Their form, their structure, and their ecosystems were unique to a specific moment in Earth's history. Today, their presence is known only through fossils, impressions of bark, petrified trunks, and microscopic spores preserved in rock. These fragments provide glimpses into a world that no longer exists, allowing scientists to reconstruct the appearance and function of these ancient forests. Yet their legacy is still all around us. The coal formed from their remains continues to power industries and shape economies. The oxygen-rich atmosphere they helped create made it possible for complex life to evolve and thrive. Even the soils we depend on today have been influenced in part by the long history of plant life that came before. There is something deeply humbling in this story. These forests were not fragile. They endured for millions of years, adapting to changes and expanding across continents. They were among the most successful ecosystems in Earth's history. And yet, when the conditions that supported them changed beyond a certain point, even they could not survive. Their disappearance reminds us that no ecosystem, no matter how vast or dominant, is permanent. The Earth is constantly changing, and life must change with it or face extinction. Somewhere beneath layers of rock and sediment, the remains of these forests still lie hidden. Silent, compressed, and transformed, they are a record of a world that once covered the planet. A world of giant plants, endless wetlands, and an atmosphere shaped by life itself. A world that vanished without a trace.